We are from Section 2 Group 4. We'd like to present our foundation engineering project. Before that, my name is Fatin Najiha. As you know, the foundation is the part of the element structure that placed below the ground surface that transfers the load from the superstructure to the underlaying of soil. Pile foundation can be used for the wet soil, so the total ultimate load capacity of the pile can be determined by summing the point bearing capacity and the resistance of friction and use the rational safety factor to obtain the value of the allowable load for each pile. In addition, the soil influenced by the structural strength. So, you need to ensure the foundation capable to withstand the load from the building to resist the settlement of the soil. Okay, next, let me introduce about the company background. The first civil and the structural consultant Sdn Bhd was established in 2050 and got registered by the Malaysian Board of Engineering and the Ministry of the Finance. Our vision is to provide the good quality services and the product in engineering solution, especially construction industry, fulfill the standard requirement, economical and the safety. And the motto, we believe in the quality, not a quantity. And this is the FAST organization chart. This project is a proposal to complete and build the gate community with 5 different types of houses located at 20017 Kampung Pait Raja Ahmad, Pai Sulong Batu Pahat, Johor, with 2 years project duration and cost estimating more than 1 million ringgit Malaysia, and have 5 different type of organization involving client, architect, town planner, mechanical and electrical, civil and structure. The reason of choosing the project location: first, the building construct in the same level of the land, avoid to landslide. Then, the work technique used to construct in every stage of development must be expected to impede the survey work, such as handling the crane, access road and the location of the material storage. For this project, 1 unit of 5-story bungalow type A will be designed. The first civil and structure consultant Sdn Bhd company are appointed to assign involving structure and civil project. The project involves the work related to analyze the load design from every column of the building, foundation and the settlement checking. In designing the work, it required to provide the safety and economic design of the foundation according to Mayoff method and recollection with a standard penetration test result. Therefore, the objective of this study are to analyze the design of the foundation and they identify the settlement checking using the engineering design format. That's all for me. Thank you.
Hello, my name is Fatin Fahawani. So now I will proceed with grouping of load. So the load under each column will be classified into 5 different groups according to its load range. So the importance of grouping of load is we do not have to design a lot of foundation, which means this can save time and also reduce the cost. So according to this pile location, we will classify the load into 5 different groups, which started from group 1 until group 5, and this is the respective loaded for each group.
Next, I will explain about the properties of the soil. The properties of the soil for the project cadangan membina dan menyiapkan skim perumahan gated community in Parit Sulong, Johor is based on the site investigation report. The soil properties such as type of soil, groundwater level and the final depth to reach the bedrock of the soil are obtained. The summary of the type of soil at each borehole is identified and the borehole location is shown in the figure and the table. This shows the 4 different locations to obtain the borehole data. Next, the summary table of borehole data. It can be concluded the final depth of the borehole for BH1 is the highest number, which is 36.0 meters compared to the others borehole data. Next, the final water depth level for borehole 2 and borehole 4, which is 6 meters. Is highest compared to the others, and the borehole depth for borehole 1 is the highest 30 meters to reach when reach the number of blow, and the type of soil for borehole data is very dense yellowish brown sand and seed. However, for the borehole 2, the presence of traces of gravel can be seen.
Assalamualaikum. For the methodology, firstly, a group of 5 persons was formed according to the project. Then, bolot and training has been found by the group members, drafted out all the important information and discussed about the calculation. Next, discussion on using slate clay, calculation and deep foundation, group member need to do the clarify to the lecturer about the calculation and drawing, and then the calculation on designing the foundation and elastic settlement done based on column selected by group member. The result obtained and answer that the question that required in the project task. So for the design of foundation, we go to the minimum group load, which is 17.64 kN to 176.77 kN. So for the tip of the pile is 21 meter below the ground surface, and the D of the pile is 0.15, and the average D and 60, we need to check it first. So for the length of pile 10D, which is we need to minus it, we got 90.5, and the length of pile 4D, we need to plus it, and we got 21.6 meter. So from the bollock, N60 is equal to 40, and next for the QP, after using the formula and we calculate it, we got 5040 kN per meter square, and the AP is we got 360 kN over meter square. So the QP is 360 kN over meter square. So for the QS, which is the formula is P times L times FAV. So for the FAV, after we calculate using the formula, we got 80 kN over meter square. And for the QS, we got 1008 kN. So for the QL calculation, using the formula which is QP plus QS over the safety factor, which is 3, after we calculate it, we got 456 kN. So the QL is bigger than the Q column, which is 456, bigger than 176.77 kN. So we can use the design. Next, for the maximum group load, the tip of a pile is 21 meter below the ground surface. For the pile D, which is 0.15, and the average, we need to use the same as the earlier, which is the minimum group load. So this length of pile is the same, and the bollock is the same. So for this maximum group load, we need to use Meyerhof method and Braut method. So for the QS of Meyerhof, we need to calculate FAVs first, which we got 80 kN over meter square, and the QS is 1008 kN. For the Braut QS, FAV is equal to 6.53 kN over meter square, and the QS is 82.28 kN. So the ultimate load of pile, which is QU, equals to QP plus QS. We need to calculate the QP first. After we calculate using the formula, we got 1890 kN over meter square. So for the AP, we got, after we calculate, we still got the same 360 kN over meter square. So the QU of the Meyerhof method is 2898 kN, and the Braut method we got 1972.28 kN. So we need to check the efficiency, which is N. We need to assume N1 and N2. So after we calculate it, we got 0.875, which is below the below 1. So if it is below 1, hence it is a group pile. So for the QU, we need to use that formula, which is Meyerhof QL equal to 3864 kN, and for Braut method, QL is 2629.7 kN. And as for the average, which is we sum that QL and we divided by 2, which is we got 3246.9 kN, which is bigger than the actual load, 652 kN, which is good. And so for the group pile, we need LG is bigger than BG. After we calculate it, we got the same 0.525. So N1 and N2 is accepted.
For the elastic settlement calculation, this is for the minimum load. The minimum load is 17.64 kN to 176.77 kN. So for the SE1, it will get 0.043 mm, and for SE2 we get 0.073 mm, and for SE3 that we get 0.0026 mm. So the total settlement from the add up from SE1 plus SE2 plus SE3 is 0.1186 meter. So for the maximum load elastic settlement calculation, the SNET that we get is 0.030 meter, which is 30 millimeter, and the SE that we get from the Q average, which is 3246.9 kilonewton, is 0.013 meter, which is equal to 13 millimeter. So the settlement pile head that we get is 43 millimeter. For the elastic settlement group pile, the settlement group pile that we get is 79.9 millimeter.
For the discussion part, the borehole tree is chosen as a reference point, which is tan, yellowish brown sand and silt. The size and length of the pile foundation are 150 times width 150 mm square part and 21 meter. The end bearing pile is used to transfer the load through the low bearing capacity soil to a strong stratum, which is a very dense sand. The end of the pile is penetrated into the firm strata until a curve, the ultimate strength of the firm layer under the pile tip. Next, allowable bearing capacity is specified for a load ground 1 until 3, while for the load group 4 and 5, the modification of group of pile is carried out. The advantages of the end bearing pile will experience a low settlement. Length of the pile used can be simply computed based on the bedrock depth obtained from the soil exploration borehead record, and lastly due to the brooding type which constructed in high-rise structure brooding.
So for the conclusion for this project, we can divide it into two different parts, which is the design consideration and also soil improvement. So for the design consideration, from the bore log we get this location contained of sandy soil type. So the proper method for construction of foundation need to be taken into account. Other than that, the location of water table also can be obtained from the bore log. So the foundation design must be considered the soil type and also the location for water table for it to make sure that it can resist a failure, such as the sliding, overturning, and also bearing capacity failure. For the second one is soil improvement. Since this location consisting of soil sandy type, so two methods that can be proposed in order to improve the compaction and the drainage of the soil, which is the sand compaction piles and also vertical sand drain.